Today we'll be having a look at this following differentiation problem involving a piecewise function. We have the function f of x, and for values of x at most 1 we have f of x equals 2x squared plus 1, and for values of x greater than 1 we have f of x equals mx plus b, and we have variables m and b. The question is to find all possible values of b and m that make f differentiable at x equals 1. So let's have a look at how to solve this problem. We can first recall, in order for f to be differentiable at x equals 1, using the definition of a derivative using our limits, we need the limit from h going to 0 of f of 1 plus h minus f of 1 divided by h. This limit must exist. And since we are dealing with a piecewise function f of x, we can have a look at the limit as h approaches 0 from the right hand side and the left hand side. From the right hand side, we have h going to 0 from the plus direction, or the right side, of f of 1 plus h minus f of 1 divided by h. And since we're going from the right hand side, we'll be having a look at what happens when x is greater than 1. So we have 1 plus h is greater than 1, so we'll be using the mx plus b formula over here, and f of 1 can be written as 2 times 1 squared plus 1. This is because the 2 times x squared plus 1 formula applies when x is at most 1, and this includes x equals 1 itself. So we can rewrite the limit like this, and also expanding the m times 1 plus h out into this. Now we can further simplify it, because we have mh over here, and dividing by h will give us m over here. And we'll also have m plus b minus 3 divided by h. And since m is a constant, we can take it out, and we get this line over here. What we can see now is if m plus b minus 3 was not equal to 0, this means as h approaches 0 from the positive direction, this limit of m plus b minus 3 divided by h is not going to exist, because it will diverge to either plus or minus infinity. The only possible option is for m plus b minus 3 to equal 0. And in this case, our limit from the right hand side, the original limit we wanted to find, we'll have m plus b minus 3 equal to 0. So we'll have a 0 divided by h. And now in this case, we don't have to worry about it going towards plus or minus infinity, because now the limit will just be 0. So we have m plus 0, which is equal to m. This is the value of the right hand side limit, and it also requires this condition of m plus b minus 3 being equal to 0. Now we can find the left hand side limit. So this is the same, except now we are approaching from the negative direction, or the left hand side. And we can recall for x less than 1, for x less than 1 or less than equal to 1, we're going to be using the 2x squared plus 1 formula for f of x. This means since 1 plus h is less than 0, we're going to be, since 1 plus h is less than 1, we're going to be using the 2x squared plus 1 formula over here for f of 1 plus h, and again we have f of 1 here. And now we can expand out the 1 plus h squared to get this line here. And now again, after expanding by multiplying by 2 here, we end up getting this line. And now, since the 2's here cancel out, we can also divide by h, and we get 2h plus 4 here. And since h is approaching 0 from the negative direction, the limit will be 2 times 0 plus 4, which is 4. So this is the value of the left-hand side limit. Now, in order for this original limit over here to exist, both the left-hand side limits and the right-hand side limits must exist, and also the limits must be equal. So we can equate these two limits. So the condition needed, remember the right-hand side limit was equal to m and the left-hand side limit was equal to 4. So this means we need m to be equal to 4. And also we have that condition from earlier of m plus b minus 3 equals 0. This condition is also needed in order for the right-hand side limit to exist. So now m plus b minus 3 must equal 0. And now if we substitute m into the second equation, we get b is equal to 3 minus m, which is 3 minus 4, and this is minus 1. Now we found values of m and b. So we can write y equals mx plus b, which is the same as 4x minus 1. And we get our piecewise function over here. So its derivative at 1, so f dash of 1 is going to be equal to 4. So that's because the left-hand side limits and the right-hand side limits are both equal to 4. So, and also this f dash 1, more importantly, this limit exists. This derivative exists. So it's differentiable at x equals 1. This completes the solution to this differentiation problem. Hope you enjoyed this video. Thanks for watching, and I'll see you next time.